Good day, everyone. I'm Ana Marie Candelaria, and today I'm going to discuss the biography, contributions, and legacy of Johann Carl Friedrich Gauss, 19th century mathematicians. So here's our objectives. At the end of the lesson, students should be able to A. Identify the contribution of Johann Carl Friedrich Gauss. B. Explain the importance of his contribution in mathematics. C. Discuss his contributions and legacy in modern mathematics. So before we proceed to our topic, let me ask you something. Are you familiar with Gauss? So if it's not, let's talk about Gauss. So here's the biography of Johann Carl Friedrich or Friedrich Gauss. So he was born on April 30, 1777 at Brunswick, Germany. Died February 23, 1855 at the age of 77 in Göttingen, Germany. He known as the Prince of Mathematics. He earned the title because of his extraordinary and groundbreaking contributions when it comes to mathematics at the young age. Also, he was a German mathematician, astronomer, geodesist, and physicist who contributed to many fields in mathematics and science. Additionally, he was director of the Göttingen Observatory in Germany and professor of astronomy from 1807 until his death in 1855. Gauss had an exceptional influence in many fields of mathematics and science and is ranked as one of history's most influential mathematicians. He came from the poor family. His mother was illiterate and never recorded the date of his birth, remembering only that he had been born on a Wednesday, 8 days before Feast of the Ascension, which itself occurs 39 days after Easter. So Gauss later solved this puzzle about his birth date in the context of finding the date of Easter, deriving methods to compute the date in both past and future years. So his mother was illiterate, it means no read, no write, and never recorded the date of his birth. So since his mother didn't know the exact date of his birth, he derived method to solve and figure out his exact birth date. Also, he was a child prodigy, so it means he's very talented and very smart. So when he was 3 years old, he corrected his father payroll calculations. Siguro nakita niyang mali yung pag-calculate ng payroll ng kanyang father. So that's why he corrected his father. Another, when he was 8, he figured out how to add up all the numbers from 1 to 100. So I will show the solution on how Gauss summed the numbers from 1 to 100. So as you can see, nandiyan yung solution ni Gauss on how sum the numbers 1 to 100. So the problem, add all the numbers from 1 to 100, 1 plus 2 plus 3 plus 4 or etc. plus 100. So Gauss method, instead of adding them one by one, Gauss noticed a pattern. So pair the numbers from the beginning and the end. So 1 plus 100 is equals to 101. 3 plus 98 equals 101, and so on and so forth. So hanggang sa 50 plus 51 equals 101. So each pair adds up to 101. There are 50 pairs total. Multiply 101 times 50 equals 5,050. So the final answer is 1 plus 2 plus 3 plus 4 hanggang sa mag 100 equals to 5,050. So as you can see, nandiyan na yung formula na ginamit ni Gauss. So yun nga, when he was 8, an elementary student, their teacher J.G. Butner gave a task to sum the numbers from 2 100. So Gauss gave the correct answer of 5,050 as faster time than expected. Gauss realized that the sum could be rearranged as 50 pairs of 101, thus he simply multiplied 50 by 101. So naintindihan po ba? Okay, and there are also many other anecdotes about his precocity while a toddler, and he made his first groundbreaking mathematical discoveries while still teenager. So later on, malalaman natin kung ano yung first groundbreaking mathematical discoveries niya. Gauss was a child prodigy in mathematics, like I've said earlier. His elementary teacher noticed his intellectual abilities. So because of his intellectual abilities, he had the opportunities to being scholar of the Duke of Brunswick. He sent to the University of Göttingen para mag-aral. So because of that, nakapag-aral siya sa isang prestigious university, University of Göttingen. So naintindihan po ba? If yes, let's move forward to his contributions and legacy. Now let's tackle the major contributions of Gauss in mathematics. Gauss is one of the greatest mathematicians of all time for his contributions to number theory, including modular arithmetic, fundamental theorem of algebra, law of quadratic reciprocity, and also the major contribution of Gauss, his books entitled Disquisitiones Arithmeticae, and in geometry, the 17-sided polygon or heptadecagon could be constructed with a compass and ruler. In algebra, the theory of hypergeometric series, and statistics, method of least squares, and formula for the Gaussian distributions. Let's tackle the first one, which is the number theory. So Gauss developed modular arithmetic and proved the fundamental theorem of algebra and the law of quadratic reciprocity. He also laid the foundation for modern number theory with works like Disquisitiones Arithmeticae. Disquisitiones Arithmeticae is a book wrote by Johann Carl Friedrich Gauss. And Gauss completed his books, his magnum opus, in 1798 at the age of 21 and published his books on 1801 at the age of 24. So meaning of the title, Investigations in Arithmetic. The impact, considered as one of the greatest mathematical framework ever written, it laid the foundations for modern number theory and influenced many mathematicians in the 19th century and beyond. The book is divided into 7 sections, 366 numbered articles, each pioneering a different part of number theory. In section 1, introduce the congruences, article 1 to 90. This is the birth of modern number theory. So, Gauss introduced the modern concept of congruence and the notation A. Congruences, B. Mod n. In section number 2, congruences of higher degree, article 91 to 163, Gauss studies the solution of f x congruence 0 mod n with f a polynomial of higher degree. Ang covers ng Section 2 is Polynomial Congruences, Criteria for Solvability, Generalization of Modular Arithmetic, and Algebraic Number Theory. Section 3, Quadratic Residues, Article 164 to 208. This is the heart of the book and contains Gauss' first proof of the law of quadratic reciprocity. It is considered the most beautiful result in elementary number theory. So the other topics is properties of quadratic residues and non-residues, the legendary symbol, Gauss sums, several proofs of reciprocity. Section 4, Binary Quadratic Forms, Article 209 to 303. This is Gauss' second great creation after modular arithmetic. A binary quadratic form is the formula and where a, b, c are integers. Section 5, Analysis of Continued Fractions, Article 304 to 315. So Gauss connects continued fraction with approximation of irrationals, quadratic irrationals, periodicity of continued fractions, solutions of Pell-type equations. Section 6, Factorization of Numbers, Article 316 to 327. Section 7, Quadratic Forms with Complex Coefficients, Article 328 to 366. So his book marked the beginning of modern number theory and introduced methods still used today in algebra, cryptography, and abstract number theory. His contributions in geometry, he proved that a regular 17-sided polygon or heptadecagon could be constructed with a compass and ruler. Siya yung nag-prove na yung heptadecagon ay pwedeng i-construct or i-draw gamit yung compass and ruler. He also made significant contributions to differential geometry, particularly through his survey of Hanover, which led to the development of non-Euclidean geometry. In algebra, he made contributions to the theory of hypergeometric series and geometric solutions to cubic equations. In statistics, Gauss developed the method of least squares and the formula for the Gaussian distributions, or mas kilala natin sa tawag na normal distributions, which is fundamental to probability and statistics. So ito yon, yan. And now, let's tackle his legacy and influences. Naming conventions. Numerous mathematical and scientific concepts are named after him, including the Gaussian distributions or yung normal distributions, Gaussian elimination, and the Gauss unit of measurements. Continuing impact, his work is still foundational in many fields of modern mathematics and physics, solidifying his status as one of the most influential mathematicians in history. Because of his intellectual abilities, nagkaroon siya ng mga iba't ibang works na mas lalong nagpatibay sa modern mathematics. So his contributions is still be used today. That's why his contributions has significant impact in modern mathematics. So any questions, clarifications? If none, that's all. Thank you.